Okay, so we are going to define significant figure and how we can express uncertainty in those significant figures, significant rules in calculations. So let's start with defining significant figure. So each number in measurement should be properly recorded and expressed properly. But if we have uncertainty, that is also going to be in measurement. So when you count significant digit, start counting with first non-zero number. Now let's look at a reaction measured by 3 stopwatches. Stopwatch A is calibrated to seconds 0. Stopwatch B to 10th of second, which is 0.0 second, and stopwatch C to hundredths of a second, 0.00 second. Now when we start recording this reaction, colorless solution, when it converts to blue solution, and we measure with stopwatch A, B and C. Stopwatch A measures 35 seconds, stopwatch B measures 35.1 seconds, and stopwatch C measures 35.08 seconds. So we can say that if a number is less than 1, a placeholder 0 is never significant. For example, let's say 0.5 centimeter, 0.05 centimeter, and 0.005 centimeter all have one significant digit, which is 5. The zeros before, leading zeros before, they are all not count towards significant digit. Only 5s in this measurement call just one significant digit. Now, if a number is greater than 1 and a placeholder 0 is usually not significant figure. So therefore, in 50 centimeter, 500 centimeter and 5000 centimeter all have one significant digit. So that way we can count significant digit if number is less than 1 or greater than 1. So when we count something, it is an exact number. Significant rules do not apply to exact number. For an example, that there are 7 quarters on this slide. They are exact numbers. Rounding of non-significant digit. So how do we round? So all number from a measurement are significant. However, we often generate non-significant digits when performing calculations. So when we round off, that means we get rid of non-significant digits. So there are 3 rules for rounding of numbers. Rule number 1, if the first non-significant digit is less than 5, then drop all non-significant digits. We'll see an example in next slide. Rule number 2, if the first non-significant digit is greater than or equal to 5, increase the last significant digit by 1 and drop all significant digits. And rule number 3, if a calculation has several multiplication or division operations, retain non-significant digits in your calculator until the last operation. Okay, so now let's take an example. If your calculator displays 15.73849 and we are going to round up to 3 significant digits. So let's say we have 1, 2 and 3 significant digits. After that we got 3 non-significant digit, which is 3. 3 is less than 5, so we drop all non-significant digits, so we can round 15.7 as an answer. And now let's say if your calculator displays 18.750019 and we need to round up to 3 significant digits. So Our three significant digits is 1, 8 and 7. After that we have 5. So according to rule, if the number is 5 or greater than 5, we add 1. So here we have 5, so we add 1 here, which is 7 is increased to 8. So our answer is 18.8. So that's how we can round number. Round the measurements 183 milliliter up to 2 significant digits. So if we keep 2 digit, for example 183 milliliter, and we round up to 18 milliliter, so that is going to be, when you see number value 183 and 18, we cannot round 183 milliliter to 18 milliliter. So for that we use placeholder 0. We can round 180 milliliter, because remember, placeholder 0 does not count significant figures. So that's why we can see in 180 milliliter we have 2 significant digits. So we can round 183 milliliter to 180, which is up to 2 significant digits. Now let's talk about rounding measurement of 48,457 gram to 2 significant digits. Now you can see 48,457 gram has 5 significant digits, and we need to convert up to only 2 significant digits. So we can put zeros. Remember, placeholder zeros are non-significant. Instead of rounding 48,000 to 48 up to 2 significant, which is not right, we change value. So that's why we put zeros, and that way we can round off that number which has 2 significant digits. Now let's talk about adding and subtracting. When you add or subtract measurements, the answer is limited by the value with most uncertainty. For example, let's say we are adding 114.3, 0.75 gram and 0.581 gram. Now you can see the most uncertain value is 0.3. You can see it has greatest uncertainty, plus or minus 0.1 gram. So whatever we get the answer, we need to round up to just 1 decimal place. Here we have 115.6. Now 6 is, we can round up to 6. Our answer, correct answer is 106.6 gram. So when you round, you can consider when you add and subtract, your answer is limited to the value of the most uncertain number, which is 1 least decimal places. Now when you multiply and divide measurements, the answer is limited by the value with the fewest significant figures. For example, when you are multiplying 2 lengths measurements, for example 7.28 centimeter times 4.6 centimeter. Now in 7.28 has 3 significant figures and 4.6 centimeter has 2 significant figures. In those 2 measurements, 2 significant figures is the least one, so we can round this number up to 2 significant digit, which is, right now we got in our calculator is 33.488, but we can, when we round up to 2 significant digit, which is 33 centimeter. So that way we can apply rules in multiplying and dividing. In next video, we'll talk about exponent numbers.